Rightio, back with question 25, rationalising denominators. So here I have 3 divided by root 7. Of course, having an irrational number in your denominator is not polite. To overcome that problem, I would like to multiply the denominator by the same thing, root 7. In order to maintain equivalence, I need to multiply the top by the same thing, because root 7 divided by root 7 is 1. I haven't changed what it's worth, so I'm allowed to put an equal sign. What do I get? 3 by root 7, 3 root 7. And root 7 multiplied by root 7 is, of course, 7. And that's all I need for that one. Let's have a look at the next one. 4 divided by 3 minus root 5. It's a little bit tricky, this one. If I square it, I end up creating that tricky middle term, which would be 2 times 3 times root 5, and it'd be negative in this case. That'd be annoying. What is it that we have to do? We have to think back. What's our favourite rule in maths? The difference of 2 squares. Quick reminder, if I have a minus b multiplied by a plus b, well, then that's a squared minus b squared. And that way, I'll have a 3 squared and a root 5 squared. And I won't have that middle term causing any problems. So we multiply by the conjugate. Instead of 3 minus root 5, we call it 3 plus root 5. Do the same to the top and the bottom. What do I have then? 4 multiplied by 3 is 12, plus 4 by root 5 is, not surprisingly, 4 root 5. On the bottom down here, I have 3 times 3 is 9, and the negative root 5 multiplied by positive root 5. When I square that term, remember, it's just 9 minus 5. Well, interestingly enough, I've got 12 plus 4 root 5 over 4. If I hadn't bothered expanding that, I would see 4 was a common factor. We can always just factorise it to get back to that anyway. 4 outside of 3 plus root 5. Divided by 4, the 4s are going to cancel, and so the answer is actually just 3 plus root 5. I hope you went okay with that one. See you in the next one.